All right, so one of the most important concepts we've already covered so far in chemistry is density. I like to think of it this way: it is your destiny to use density in chemistry. So, in this exciting chapter, you're going to need to be able to describe density, calculate density, and if I give you some basic density questions, you should be able to answer them. For example, I may give you density and volume. You should be able to tell me the mass. Or I can tell you density and mass, and you should be able to give me the volume. Yes, Emily. So you'll need to come and get one. They're right there. There. All right. So look at these two bricks. One is a brick and the other one is a styrofoam brick. Notice that the brick weighs a little bit more, even though they are exactly the same volume. Exactly the same volume. Can anyone tell me why the brick weighs more, even though they are exactly the same volume? Joey, it is more dense. Okay, so you're using some keywords that really and truly you probably don't understand. Maybe you do. Can you explain to me what do you mean by dense? Some people will say, very good job. That is correct. Some people will say that the molecules of brick are bigger than the molecules of styrofoam, and they would be wrong. Styrofoam molecules weigh more than brick molecules. So let's look at them under the microscope, and you will find that Joey is correct. Notice these big, giant white styrofoam molecules. They're big and they're giant, but they're spread apart. The way they pack together leaves a lot of empty space between them, while the brick molecules are going to be more closely bunched together. And this is why we use styrofoam for what? Raise your hand. Raise your hand. Why do we use styrofoam for? Trying to make this as practical as possible. Nick, packaging? What kind of packaging? Any kind of packaging? I'm not talking about the styrofoam little things. I'm talking about styrofoam Oz. Packaging TVs. Okay, so they're very light, so it's good for weight, because a lot of times UPS and these companies, these trucking companies are very concerned about the weight. So you want something to kind of cushion the TV, but you want it to weigh very, very little. So styrofoam's great, but that's not what I'm thinking about. What am I thinking about? Styrofoam coolers. Why do we use styrofoam coolers? Raise your hand. Bree. Okay, actually, it can't keep cold in because cold is nothing. Cold is where there is no heat. What it's keeping out is heat. So inside our cooler, we might have some sandwiches. We want those sandwiches to stay nice and cool. So here comes the heat from the outside. What does the heat have to do as it's coming in from the outside? Is there a direct path from, let's say, this is where your sandwiches are, this is outside. As the heat comes in, what does it have to do? See what's going on here? It has to go a roundabout way. What about the brick? Much more direct path. So what you're going to find is because we have a lot of empty space between the styrofoam molecules, heat has to move more. It has to move faster. You know your sandwich eventually is going to warm up, right? Question is, can we delay it long enough so that when you are eating your picnic, or if you have a Coke in the cooler as well, it's still cold, right? Your insulated, your insulated uh, mugs and cups. Guess what they used to have in them, in between the layers? Styrofoam. What do they have now? I don't think it's styrofoam, but once again, it's going to be something that's going to be really not very dense. It's going to be a lot of empty spaces. Your windows, my friends, your windows. If you've got a nice window, like we used to buy our windows during the winter months, you could, on the inside, you could feel the glass and it was cold, like really cold. Sometimes when it was really, really cold outside, there would be frost inside our house on the windows. Okay. What did that mean? That meant that heat was leaving. Heat was leaving my house. And heat was leaving my house so quickly that it was the moisture, my windows were getting really, really cold. Now I have windows that have between the two panes a vacuum. That means nothing. So in order for the heat to move, it has to go into the window, go up the frame, through the frame, and down the other side of the window and out. That makes it more difficult for heat to come into my house and heat to go out of my house, keeping my house a little bit more stable when it comes to temperature. And the whole key thing is you're making heat have to move farther. And things that are not very dense make heat have to move farther. Any questions on why styrofoam is so important? All right. So, what is density? Density is how much stuff or mass is crammed in a particular amount of volume of matter. It is measured as mass divided by volume. Mass divided by volume, or mass per volume. The units usually grams divided by milliliters. Grams divided by milliliters. Got it? Let's look at some densities of common materials. Oxygen, which is a small part of what we breathe, right? What's mostly what we breathe? Who remembers? Nitrogen. What do you breathe in mostly? Nitrogen. What do you breathe out mostly? Nitrogen. Nitrogen. Okay, it's about 80%. Cherish, you got to, yeah, that, don't like that at all. At all. Okay. Never again. Uh, Most of what air is nitrogen, 80%. The rest is oxygen and a teeny tiny little fraction of other gases. Okay? So when you breathe in mostly nitrogen with a smaller amount of oxygen and teeny tiny amounts of other things. When you breathe out mostly nitrogen with a somewhat about instead of 20% about 15% oxygen, and then you're breathing out about 5% carbon dioxide. That's why CPR works, my friends. Carbon dioxide will kill you. So what happens if somebody's not breathing and you're breathing out your exhaust and it's carbon dioxide? What would you do to them? You'd kill them. Okay, no. What you're breathing out is still enough oxygen for them to use. So you breathe out. Not to mention, I mean, people will be kissing, and pretty soon they both faint because they're both breathing into each other carbon dioxide. No. What you are breathing out when you're kissing somebody is still mostly nitrogen and oxygen. Water has a density of 1. Ice. Why does this make sense? Why is this important? Raise your hand. You can look at these two numbers and tell me, whoa, that's important. That makes sense. Anybody? Yes, Joey. Ice floats on water. Now, for us, because we're so used to water, because water is so important, that's no big deal. You do realize that every other liquid known to man, the solid will go down to the bottom. It's ice sinks. Everything else, it's ice sinks. But water's ice floats. We don't know why. It has to do with the way that water connects to other water molecules, but it's extremely rare and very strange. And if it didn't do that, life would not exist here on Earth. Can anyone tell me why? Winter months, where it's really, really cold, where it's so cold that the water in a lake or in an ocean will freeze. Where does it freeze? Raise your hand. Where does it freeze? Charlie? On the surface. The food cycle begins underwater, begins down at the bottom. What if water was like everything else and would start freezing down at the bottom? What would happen to the food cycle? It would fall apart. Everything would die. So you can have a lake or a pond completely frozen over on top with water, with ice, and on the bottom you have fish, crabs, shrimp doing their own thing. Ethanol, drinking alcohol, a little less than water. Aluminum, about 3 times more dense than water. Iron, copper. So, what is the density of water again? 1. That is really, really cool. Okay? Because that is going to allow us to convert easily. That tells you something. It is 1 gram when you have 1 milliliter. So if you have 20 grams, how many milliliters do you have? 20. If you have 30 milliliters, how many grams do you have? If you have 100 grams, how many milliliters do you have? It's the same number. So water is perfect. However much mass you have, that is how many grams. That thing, I've known that for many, many years, but really it's only been in the last year that has really come home to me, for me to understand. Because some of you know that last year at this time, I weighed almost 240 pounds. I was fat, okay? And then I had to go on a diet because my knees were a wreck, and I now weigh 180 pounds, okay? How did I do that? Basically, it's called the keto diet or low carb diet. Now, one of the most interesting things that happened to me is, as you start losing weight, you get encouraged and you want to weigh yourself. So I made the mistake of weighing myself all the time for those first few weeks. First of all, I lost about 10 pounds the first week. Now, I didn't lose a lot of fat, but I lost a lot of weight because if you're not eating a lot of carbohydrates, you don't need a lot of water in your system. So my body started getting rid of a lot of the excess water that I have. Okay, you football players and basketball players can relate to this. Okay, because you can lose a lot of weight in the course of one game, can't you? And where is that weight coming from? Water. So I remember one time I weighed myself right before I went to bed, and I weighed like, let's say 203 pounds. Then as I'm laying there, I'm going, I need to go to the bathroom. So I went to the bathroom, did number one. I go, I wonder. I lost a whole pound. Okay. I lost a whole pound. Why? Because I probably did number one for about 100 milliliters. 100 milliliters is, it's probably about 200 or 300 milliliters. That's almost a whole pound. So, yeah, you can lose by going to the bathroom. You can lose weight because you are losing fluid milliliters. And for every one of those milliliters of urine, you will lose 1 gram. Actually, probably a little bit more because urine its density is a little bit more. Weightlifters, I'm not weightlifters, people who wrestle, they have to stay within a certain weight limit. They make sure that before they weigh in, they either drink a lot of water or they make sure they urinate a lot of the water, okay? Because they want to stay within that weight. Yes. All right, thank you. Cherish, now you need to go to the office. If you drink a bottle of water that is 500 milliliters, how many grams will that be? 500. Same thing. Same thing. Converting from grams to milliliters is going to be the easiest thing. If your recipe called for 60 grams of water and you don't have a balance scale, but you do have a measuring cup, how many milliliters of water will that be? 60. What is good for grams is good for milliliters. In chemistry, it will be very useful to be able to convert from one to the other. From one to the other. Okay, so what formula will we use? Density formula. D is equal to M over V. Mass over volume. Mass over volume. D is equal to M over V. Mass over volume. Hope you guys are copying these notes down because there will be times in which I will check your notebook and give you credit for it. And of course, you need it, as you've already seen, in order to do quizzes and tests. Okay, so some of you are sitting there going, okay, mass over volume. So what's mass? And that's what today we're going to be figuring out, what mass and volume are. Mass and volume. So what is mass? It's a measure of how much matter an object has. It is a measure of how much matter an object has. So The next question is a very interesting question. What's the difference between mass and weight? Is it the same thing? Actually, no. Who can tell me what the difference is between mass and weight? Yes.
Mass is how much like space it has, and like weight is how much like heavy it is,
What's heavy?
or like or how much it weighs,
You're using weight. You're using weight in the definition.
right?
Okay, Oz, what if I was to tell you that uh, I think like 89 kilograms here on Earth. And in space, I still mass 89 kilograms. But here on Earth, I weigh 180 pounds. And in space, I would weigh maybe 2 or 3 pounds. Can you figure it out?
Yeah, the gravity.
Ah, he's got it. Weight is dependent on gravity. Weight is the effect that gravity has on you. You want to lose a few pounds? Go up to the top of a mountain and weigh yourself. You want to gain a few pounds? Pick up your balance and go down to Death Valley and weigh yourself. The closer you are to the center of the earth, the more you will weigh. The further you are, the less you will weigh. So weight is dependent on gravity. So you stand on one of those spring scales and there's springs there. So that's the reason why it's called a spring scale. So when you stand on it, the springs get compressed and that's connected to the dial. So it is determining the force of gravity on you. But can you step on a spring scale in the space station? No, you try to step on it, you probably bounce up because you have very little weight. So there has to be a different way of measuring that. The instrument that we use to measure weight is called a spring scale. A spring scale. That is a spring scale. So the heavier something is, which is what Oz used the word heavier, the heavier something is, the further along it's going to push this dial. But mass is a whole lot better. Weight can change depending on how far you are from the center of the earth. Weight can change. Weight can change depending on how far you are from the center of the earth. Mass is better. Mass is going to cancel out gravity. Mass is a measure of how much stuff you are compared to things that we know. It's called a balance scale, and I will explain to you as soon as you're done writing this. I will explain to you how it works. It's called a balance scale. This will work in the moon as well as in space as well as on the earth. We have 3 more questions to go after this one. So we're almost done. I don't like to talk this much. We'll take a quiz right afterwards. We got it? A little more time. You don't have to put that last statement about the moon. You just have to put balance, scale. Okay, so how do we know the mass of Isaiah? How can we can determine its weight with a spring scale with this guy? But I think in the training room you actually have a mass scale. Is it do you guys in the training room to have one of those where you stand on it and there's these weights that you slide over? That's a balance scale. That is determining your mass, not your weight. Okay, this is how it works. So you've got Isaiah, put him on one side of the pan. Does that look like Isaiah? Fingers now, right? That looks like Isaiah. Okay, no, that's his head. He's got hair. Is that better, Isaiah? All right. So what's going to happen to this scale if you put Isaiah on one pan? It's going to go down. So what we start doing is we start adding weights, things that we know exactly how much it weighs. Okay, we start adding weights to this side until what happens? Until it evens out. How do you find his weight, his mass? By adding up all the weights that you put on there. Maybe on Sundays in Sunday school or at church, you learned about there was a time in which Jesus drove out the money changers in the temple. What was going on? Well, what would happen if you're bringing in some stuff, some money to exchange for other money? They're going to weigh that money because that's how they measured. They didn't have like different denominations. It was a certain number of gold pieces or a certain number of silver pieces. And what they would do is they would compare it to weights that they were saying, oh no, this is a shekel. Trust me, this is a shekel. Well, what if the shekel, that really wasn't a shekel? What if these weights were wrong? What if they were bad weights? Then what was going to happen? You were going to have a bad weight, a bad measurement. So Jesus got mad because these money changers were trying to cheat the public by using different weights. That's why you got to be very careful. So Isaiah goes up to the balance scale in the training room, and he gets on that. That's like getting on this side of the pan. And then it's hooked up to these weights, right? One weight is 1 gram, one weight is 10 grams, one weight is 100 grams, one weight is 1,000, and he slides it over until it balances out. That's like balancing out this scale. So you are comparing Isaiah's weight to the weight of those different weights on there. Since gravity is pulling them both the same way, it works. Take it up to a high mountain, is gravity going to be pulling down on Isaiah and the weights the same way? It works. Take it over to the moon, even though they only have 1/5 our gravity, will it work? Can you find the mass? Yes, because you're comparing something you know to something you don't. These are electronic. This is what we're going to use tomorrow in the lab. Okay, what they did is they designed the electronic scale, and then what they're going to do is they're going to press a special button and they're going to put a 1 kilogram weight on it. And then they're going to hit the button. And the computer in the scale is going to say, so that's what 1 kilogram weighs like. Got it. I understand. It remembers what that felt like. to have a kilogram on it. And then we're going to place tomorrow different objects on the scale. So the computer's going to go like this. Okay, this weighs this much, and this is what a kilogram weighs like, and it's going to tell you the number. It's going to compare what you put on that pan to what it felt like to have a kilogram on it. What do you think so far? We're almost done. So what is volume? How much space an object takes up. It is measured with a graduated cylinder. In the real world, it's a measuring cup. And volume is also not very reliable because volume can change with temperature. Weight changes with gravity. Volume changes with temperature. After you're done, you can put that away, leave your notebook out, take out your computers, and turn to quizzes. Quizzes. Get on quizzes. You might want to leave your notebook out because you can use it for the quiz. This is a graduated cylinder. This is what we're going to use tomorrow. Slabs of concrete. Why do you think they put a space between pieces of sidewalk? Does anyone know? Yes. Yes, they don't want it to crack. Why? Why does it crack? Conlon has his hand up. Because as the temperature goes up, the concrete expands. Its volume changes. But what if you have a very long piece of concrete? One is under a tree and one is in the sun the whole day. As the sun part expands, it's going to hit the one that's under the tree that's not expanding as much. And that's where it cracks. Okay, they're called expansion joints. By leaving that crack there, it allows the concrete to expand into the empty space. Make sense? So now we know why expansion joints. So the next time